Okay, hello everyone, and thank you for joining us for today's webinar. My name is David Frangiosa, and I'm the Senior Marketing Manager for Megaport in the APAC region, and I'll be your host for today's Megaport Live webinar. Today's topic is What is NaaS, presented by Mark Austen, and I'll shortly hand over to Mark, but just a little housekeeping before we get started. We are recording today's webinar, and I will post the recording to our YouTube channel and website shortly after the webinar. We will have all participants on mute for the webinar, so please use the Q&A panel to ask your questions. The Q&A panel is located at the bottom of your Zoom screen. You can type questions in at any time during the webinar, and we will answer them via text reply during the webinar. If you experience any issues with the Zoom interface, please try logging out and logging back in. If that does not resolve your issue, please contact Zoom via the help button, which you'll find in the top toolbar. I will now turn the time over to Mark. Thank you.
Hi everyone, welcome to the webinar on what is Network as a Service. Thanks Dave for the intro. So again, my name's Mark Austen. I'm a solution architect at Megaport. I look after the Australia and New Zealand regions, so working with customers, our customers and future customers in this region. And I'll be taking you through the session today. So this session is an introductory session on what is Network as a Service. So it's a high level session. It'll run probably for around 30 minutes or so. So what we're going to cover today is, of course, what is Network as a Service, how NaaS differs from infrastructure as a service, platform as a service, and software as a service. And we'll look into what's driving the adoption of Network as a Service, how Network as a Service is implemented, the benefits, the use cases, and finally, the future of NaaS. So again, if you've got any questions, put them in the Q&A chat, and Ryan, my colleague, another solution architect who's based in Australia here, he'll answer those for you. So let's kick off with how Network as a Service differs from IaaS, PaaS, and SaaS. So infrastructure as a service, IaaS, provides you with the basic building blocks that you need if you're going to use cloud-based IT. This could be in a public cloud or something you're doing in your own private cloud. It's giving you the building blocks such as network, compute, and storage, and giving you complete flexibility to deploy your applications on top of that networking, compute, and storage. So full access and flexibility, but more work involved for you to deploy your applications. With platform as a service, you only have to focus on the management of the application and data. So the platform as a service provider takes care of the hardware and operating systems. You just manage your application. There's no need to worry about the complexity of the underlying infrastructure and the operating systems. So some examples of PaaS are things like AWS Lambda, Google App Engine, and Azure Functions. So, they're cloud-based PaaS offerings, essentially. Very, very much application focused. So with software as a service, of course, you don't have to worry about any of the maintenance and operation of the infrastructure or the applications. It's just taken care of by the software as a service provider. So software as a service is generally a subscription-based service, and some of the examples of SaaS are things like Salesforce, Gmail, Dropbox, things you use daily. All of the SaaS services abstract away the underlying complexity, so you don't have to worry about it, but it still gives you some controls on how it's set up and integrated with your systems. So Network as a Service, which is what Megaport offers, is cloud aligned. service model. And this is where you are going to the network as a service provider, and instead of building your own network, you're allowing the network as a service provider to look after the full life cycle management of the network infrastructure. That includes things like network management, software licensing, all of the hardware and connectivity that's required to deliver network services. So the cloud-aligned service model of the NaaS provider allows the end customer to consume NaaS services on demand, and they can build what they need through the self-service portal or through an API offering. So the network as a service provider really simplifies the deployment of services, which can be based on either short-term or long-term subscription models. So it's very much a cloud-aligned model of using networking. And what we're going to do here is just pause for a sec and post a question, a poll essentially, and that'll appear shortly. If you don't mind filling that in, and we'll see what the results are in a minute. Okay, I think that's probably enough time for everyone to have filled that in. And I think any minute now, you'll see those results. So there you go. So a lot of people are looking to move some of their IT infrastructure to an as a service model. Thanks for doing that. Okay. So digging a bit deeper with network as a service. So what service can you deploy on network as a service? You can pretty much do everything you can do if you built your own network infrastructure. So you can do it faster. You don't have to worry about the underlying infrastructure. And some of these, for example, like things like virtual routing, private connectivity to cloud, multi-cloud connectivity, so connecting more than one cloud provider together privately. You can do virtual firewalling, so spin up a virtual firewall on the NaaS infrastructure and use it immediately. You can also procure internet services and internet exchange services. This is just some of the examples of what services you can deploy using network as a service. But so where can you do this? Generally, when you're looking at a NaaS provider, they're available in global locations, obviously where the network service is provided, but very much it's a global deployment. And being globally available enables you to build an ecosystem of connectivity with other partners. So for example, you connect to the network as a service provider, ask your partners or companies you work with to join the same network as a service provider and connect privately and instantly over the software-defined network. So you can do hybrid cloud networking, connectivity to multiple clouds, public clouds, and also connecting that connectivity back to the on-premise for private cloud as well. So you can mix and match the environment. You can build a resilient network infrastructure as well. You can connect from data centers to other locations around the world, also from branches over the internet, or from say a head office or any corporate location. So NaaS offers all of that capability. So what's driving the adoption of network as a service? So we've been looking at some research from different sources. So from ESG Research 2022, from FlexZero 2022, and from Checkpoint Research 2023. So looking at common challenges organizations have been experiencing when connecting to cloud. Network costs are obviously top of mind, and a lot of decisions about moving to cloud are made from a financial viewpoint. And organizations have been looking at reducing the costs, obviously, where necessary. And what they find is often when they want to connect to cloud, the costs can be prohibitive. So network complexity, moving on to that, can also be a big factor. What was captured in those reports is, 60% of organizations will use more than 4 cloud providers. And there's a lot of different use cases with those cloud providers. So we touched on those. You're looking at IaaS, PaaS, SaaS. And companies are mixing up the usage of cloud. So when connecting to cloud, it's becoming more of a challenge. So looking at network performance, again, that's always top of mind. How do I design my network with resilience in mind? How do I make sure I have redundant connections at every point in my network? So as more companies, they move into cloud and cloud adoption increases, optimization of costs also need to be considered. So you don't want to let it get out of control. Quite often, organizations will move to the cloud quickly and they'll look at cost optimization later. So one thing that can help with that is a cloud center of excellence within the organization. And that really plays a large role in cloud governance and how the costs of cloud are kept under control. And finally, the security risks. Of course, it's always a concern to be able to protect your data to and from the cloud. So network as a service can help with all of these points that you see here on the slide. So really it provides private connectivity to cloud, simplified connectivity between clouds, cost reduction, and also high network performance. So what makes network as a service different when you compare it to traditional connectivity? So on the left, you've got network as a service. On the right, you've got traditional connectivity that you might procure from, say, a telco or another network service provider. So pricing, you pay for what you use. Typically, there's no setup fees. Compared to a lot of traditional providers, you're locked into long-term contracts and large setup costs. So NaaS doesn't have that. If you're not looking at long-term, you can do a short-term subscription model. So this does tie in to the network as a service provider being aligned with the cloud consumption model. So that's hour by hour, month by month billing models, or longer term contracts if that suits your requirements. So with network service, it's real-time provisioning down from months to minutes, elastic capacity, increase or decrease the speed of connections to suit your requirements, or just turn on and turn off connectivity, again, to suit your design or your requirements. And the NaaS providers, we've already created connectivity to many of the third parties, including all of the major cloud providers globally in many locations. So this has created extensive reach and diversity. And if you're using a NaaS service, it gives you full control and power over your network services. So for example, that is deployment, modification, deletion of services, all done instantly through the simplified portal interface. So there's no need to submit order forms, through an email or call someone to follow up. So services are deployed instantly and are ready to use straight away. So let's have a look at how network as a service is implemented. And network as a service, a lot of the infrastructure, it lives inside data centers. These are the data centers that you can see on this slide here, some of the major data center operators, and the infrastructure is deployed in locations globally. So the NaaS provider has a common deployment model that's easily rolled out to all of these data centers. And the data centers are connected together, of course, using a global backbone network, in a resilient architecture. So you don't need to worry about that. your services run over the top, with protection. So the benefit of being in multiple different data center operators, it means that customers have the choice of where to connect onto the network as a service provider. So, you can see here a large amount of different operators there, and you choose the access point into the software-defined network that suits your requirements. So you're not tied down to one data center operator. It allows, again, different data centers run by different data operators to be connected together over the NaaS network. So when you look at the map of a NaaS provider, they'll typically have major metros around the world enabled with their network. So this means a global deployment requiring the NaaS provider, of course, to have the regulatory compliance to operate in that country. And within each metro or city, you have many different locations to connect into, because there'll be many different data center locations enabled, of course, by that NaaS provider in that city. So it gives you many options, within a city. Typically, when you're looking at the NaaS provider, it'll be in the popular data centers and the data centers where the cloud providers have their private on-ramps. And being in those data centers means that NaaS provider has the connectivity to the likes of AWS, Google, Azure, Oracle, for example. And with that connectivity already in place, customers don't need to worry about building that dedicated connectivity to each of those cloud providers. The customers just connect to the network as a service, and they consume that connectivity, the private connectivity, instantly. So how do users consume the services? So typically through a portal. You can see it on the slide here at the right. That's what a portal looks like. The users log into the portal. They create the new services, they connect them together, they connect to the cloud, they connect to third parties. They can look at logs, they can look at traffic statistics and details, and just generally manage the life cycle of those services through the portal interface. And most network as a service providers provide an open API. So if you want to consume services through an API, with a preferred programming language, like Python, for example. Or you could use other tools like Terraform, which provides a higher abstraction layer to the API. So infrastructure as a code, essentially. So what about the benefits of using network as a service? So we've touched on these a bit before, and we'll just go through a few more here. So you can, of course, on-demand scale. You can build what you need when you need to build it. So you don't have to, again, submit an order form or wait 3 months for something to be deployed. You just go to the portal and you build on demand. Very much cloud-aligned model of building network services. So when you're doing that, the simple tools that are provided. So you've got a simple user portal, which is very much, can be driven by most IT teams, or you've got more advanced tools like infrastructure as a code. So you could really automate the services using the API or something like Terraform. So that fits into a lot of the cloud deployment models and the cloud workflows. So the network, of course, is typically private and secure. So your traffic is not transiting the internet, it's transiting a private network. And the infrastructure is built at very high capacity, the standard interfaces that you're connecting out at 10 or 100 gigabits per second. And the network fabric of the NaaS provider can easily absorb that amount of traffic. So enabling you with the high-speed, private, secure connectivity to the cloud, or between data centers, or between your partners that you work with. So it's all scalable, on-demand connectivity to a global ecosystem of service providers. and with flexible terms. So you're only paying for what you use if that's the operating model that you want to go with. So we're just going to have a look at some of the use cases to see what can be achieved with NaaS. And this example here on the slide is connecting to public cloud regions from a data center. So the data center is on the left, just to give you an idea of some of the top cloud service providers that Megaport connects to. They're on the right. And the cloud providers are connected to the NaaS network already in different regions globally. So they're all the private on-ramps physically connected to the NaaS network. So they're connected again over the software-defined network that the NaaS provider is using. So a user could could choose to connect to the network as a service provider in the data center. But there are ways to jump onto the NaaS network with internet connectivity as well. But if the user is located in the data center, they can connect to the NaaS provider there. And from there, they can connect to all of the clouds at high speed over a private network. So for example, for AWS, you'll be connecting, the NaaS provider will be connecting you to AWS Direct Connect. For Microsoft Azure, you'll be connected to ExpressRoute. For Google Cloud, you'll be connected to Partner Interconnect. So that's the private on-ramp offerings of those cloud service providers. So if you need resilience, you can connect in another data center or a different zone in the first DC, and you can ensure a resilient design to all of the cloud providers. So that would be resilient on the left-hand side there in the DC, but it would also be resilient on the right-hand side to the cloud providers as well. So because all of the cloud providers provide redundant interconnects in the metros where they offer the private on-ramps. And, the leading network of service providers will connect to all of those on-ramps to provide you the resilience in your design. So what if you don't want to connect from a data center or an on-premise network? Well, in this case, as you can see here, you can spin up a virtual router in a location that suits you in one of the major metros globally. So, a metro being like Sydney, Melbourne, Auckland, Singapore, etc. Okay, so you spin up the virtual router through the NaaS portal to meet the throughput requirements you need. So, you'll spin it up at 1 gig, 2 gig, 5 gig, 10 gig from a throughput perspective. And then what you do is build the virtual connections to the cloud providers' private on-ramps that we talked about in the last slide. So that lines from the virtual router to the private cloud on-ramps. So with this type of deployment, you can route cloud to cloud with the virtual router at high speed across the private NaaS network. So traffic is not transiting the internet, it's all private from one cloud to another. And typically the cloud provider on-ramps and the virtual router will be located in the same location or the same data center. And that gives you, very much a real low latency connection between the cloud, between each of the clouds. And that can be built on demand through the self-service portal or through the API. So you can spin it up, spin it down, all automatically. So all of these services, again, can be, of course, deployed without interfacing to anyone at the NaaS provider. You build it all automatically. So you log in to the portal, spin up the virtual router, create the connectivity. It's all under your control. So if you need a resilient option, of course, you can spin up another virtual router in another location, and everything will be independent and redundant. So the NaaS provider will have full resiliency. The cloud provider on-ramps will offer, again, full resiliency. So we're bringing, on this slide, we're bringing everything together. So you've got data center connectivity and the virtual routing as well. So this is where you're building a hybrid multi-cloud architecture. And all of the cloud-to-cloud traffic is only transiting the virtual routers. Anything that needs to connect from the data center to the cloud can do so by transiting those virtual routers. So what this provides is, simplification and optimization of the hybrid cloud design. So there's no need to extend, the routing relationships like BGP all the way back to the data center. The virtual routers become essentially an aggregation for all of your cloud connectivity into the data center. So it removes any unnecessary hairpinning of cloud-to-cloud traffic back to the DC. So overall, reducing the complexity in the data center with a simplified virtual cloud router deployment. So we're just going to pause here for a minute, and we're going to post another poll. So if you don't mind answering that, and we'll have a look at the results. Okay, so how many cloud providers are using or planning to use? Sort of equal there, 2 or more, data center, 1 or more clouds. So great, thanks everyone for answering that. So let's look at some feedback from network as a service customers or users. So, the first one there is eliminating VPNs, internet-based VPNs, while connecting to AWS spot instances on demand. So reducing cloud-to-cloud egress fees by half and driving, lower cloud costs. So the spot instances, they need to be consumed at a certain time, possibly at high speed. So instead of trying to do that over the internet, the users can connect privately and have a flexible connection. So the second one is automated multi-region, multi-cloud network deployment using APIs. So with network as a service, you can do all of your deployment with APIs across regions globally. So when looking at a network service provider, the infrastructure, the offerings are the same across regions and globally. So you can use the same model globally. So use case 3, which is a large SAP HANA migration to cloud example. So similar to use case 1, the flexibility and high speed that the network service offers cuts down the time from on-prem to cloud data migrations. So pretty straightforward, high throughput, private connectivity. Number 4 is about connecting 7 unique data center operators around the globe, connecting through a single platform. So network as a service has a large data center footprint globally, as you saw earlier. So services can be deployed easily and across many different data center operators. And number 5 is about deploying a global multi-cloud design for 9,000 plus user base of engineers across 3 regions, 3 clouds in under a week. So with the large global footprint of data centers and private cloud on-ramps that NaaS is connected to, a global architecture can be deployed within minutes. And I've got an example of that in a minute. And use case 6 is about reducing latency by half with a large increase of bandwidth while lowering costs. So what this is about is internet-based SD-WAN deployment in combination with network as a service. So providing SD-WAN networks high-performance access to multi-cloud. So what does it look like if someone deploys network as a service in a region or globally? So this example of is a global deployment, but this could just be, say, within the APAC region. But walking through this example, there's a virtual router deployed in the US region, connected to 2 clouds and also multiple data centers in different parts of the US, so all privately. In Europe, there's just a single data center location connecting into multiple clouds. So you can see there, including Google. And over in Singapore, there's an SD-WAN edge running on the network as a service provider, connecting SD-WAN branches in that region to AWS and Azure. So the SD-WAN device running on the NaaS provider also has private connectivity across to Australia and a data center in Japan. So all of these elements are connecting over a global backbone, which is provided by the network as a service provider. So it's a private backbone. It's not transiting the internet. So everything shown on the topology is a private service running on private infrastructure. So what about the future of network as a service? Let's just have a little bit of look at that. So I'll cover the topics of SaaS and machine learning or AI. So SaaS is a term, or is a term created by Gartner. They came up with an architectural model which is based on network and security services. So there's 5 core elements to that architecture, and one of those is SD-WAN. So software-defined wide area networking. So being able to connect using many different types of network transport by essentially building an overlay, private overlay over the top of that transport. So typically SD-WAN is deployed using the internet as transport, but it can be easily deployed on top of a network as a service provider as well. So, you know, running over a private network. And SD-WAN topologies, they're typically deployed in a hub and spoke topology. So as a NaaS provider, it can host, the NaaS provider can host the SD-WAN hub, for example, and this can act as a gateway to cloud connectivity or connectivity to an SD-WAN hub in another region. So other elements of SaaS that can be hosted on a NaaS provider include firewalls or secure web gateways. So in considering SaaS deployments, take a look at how the NaaS can fit into the architecture. Another hot topic is machine learning and AI, and there's been great inroads to machine learning, and many network as a service providers use machine learning in their networks today. So the areas this is being used is mainly focused around a few areas. One of these, you know, is finding remedies or to faults or issues quickly. So just finding the root cause of any issue and telling the user, you know, what that is, instead of providing, you know, them with lots of alarms, it can help narrow down the issue to only the required information. The other one is real-time provisioning. So allowing machine learning or AI to understand your network, understand how to use your network, your typical trends, and then right-sizing the network for you. So it could just give you an alarm, or it could make the change for you. So another area is the rise of network function virtualization. So if you wanted to deploy your own network function, virtual network function, you could get your own hardware, deploy it in a data center, and you could deploy the virtual software on that. But you're still having to manage the hardware, you know, and maintain a footprint in a data center when potentially you don't have to. So you could also deploy that inside a cloud in the major cloud providers, or you could deploy it on a network as service provider. So what we're seeing is a big trend in virtualizing these elements. Instead of buying the physical hardware for your routers or your firewalls, we're seeing more and more users moving to network function virtualization. So using software versions made available by the network and security vendors. So for example, Cisco, Fortinet, Palo Alto, these are equivalent features to the hardware platforms. So as more and more users move to the cloud, they also move more to a virtual model and virtual architectures. And that brings us to virtual connectivity hubs. So if I blow up one of these virtual connectivity hubs, you'll see here a virtual connectivity hub can be made up of many different elements. In this example, we've got an SD-WAN network connecting in through some SD-WAN hubs, which are running on the NaaS provider, and then going to a firewall layer, then going to multi-cloud. This could also be a virtual routing layer connecting to different data centers. But the trend we're seeing in the network is where enterprises are creating these virtual connectivity hubs, typically in a metro or across a few locally deployed metros, and deploying them in a resilient way and replicating the design in different locations around the world. So the NaaS provider being global infrastructure that you can deploy the same model in a lot of different locations globally. And then they're using the network as a service provider, the service provider's backbone, private backbone, the red lines you can see between these hubs to connect them together. So that's all on demand, increase speed, decrease speed, delete, create, through the portal or through the API. So it's all private connectivity between the virtual hubs, and it gives them access to all of the virtual routing capabilities they need. So firewalling capabilities, resilience, onboarding of SD-WAN, hubs, and all of the cloud access they need at high speed and private. So that's, we just wanted to touch a little bit on that with virtual connectivity hubs. So that brings us to an end of the webinar. Thanks for joining. You can see my contact details there at the bottom of the slide. We thank you for your time today, and thanks for any questions you posted, and also for filling in the poll. And I will hand back over to Dave. Thank you.
Thank you, Mark, and thank you everyone for taking the time to join us today. We'll be hosting these quite regularly, so keep an eye on LinkedIn, Twitter, and email, and our website for upcoming topics so you can register. If you've got any more questions or would like a member of the team to contact you, please complete the form that I've posted in the chat functionality. Thank you again for joining. I'll now close the call and hope to see you at our next Megaport webinar series.